Alright, sports fans, here we are back. We are in third video now of Unit 8, and today we're going to talk about rational exponents, okay, as part of our equivalent expressions unit. So what really is a rational exponent? Well, a rational exponent is an exponent that's used to indicate a root function, either a square root, cube root, fourth root, so on and so forth, right? The way this works is, so this is the square root of x, all right? So we have to look at this and say, all right, so what do we write? So a rational, remember a rational is any number that can end up being a fraction. So any number that you can write as a fraction is considered a rational number. So here we have this, so this is taken to, basically we're taking the second root of x, this the square root, all right? So we can write that as x to the 1 half. Because the way this works then is you have x to the 1 half, and if we square x, if you square a square root, it cancels out. So what happens here is, with our exponent laws, this means the same as 1 half times 2, which ends up being x to the 2 over 2, which becomes x to the first power. All right, and that's the way our rational exponents kind of create that 1 half approach, so we can get what would be the square of that, which would just be what x is as the term. So let's think about this one. So here we have 4 in our root, and we have an x to the third. So how we write this is x to the denominator was our root function up here, so the denominator is still going to be our root function down here, and our numerator is going to be the power of x inside. So that'd be x to the 3/4 power. So kind of the general rule as we're looking into this is, so if you have a number, x, taken to the a power, taken to the b root of that power, well, you can rewrite this as a rational exponent of x to the a over b power. Okay, and that's kind of the general form. So the denominator will always be the root function, and then our numerator will always be what the power of x is under that root. All right, so let's maybe see an example of what it's going to look like. So for the most part of this unit, we're not going to be using these to solve a whole lot. We're just going to be rewriting them into equivalent expressions. So the best way to do this is kind of just take one and just go as far as you can with it. Really kind of play with what's going on instead of maybe just doing the 1 or 2 that we want you to do for homework. All right, so here I can see this is root 3. So I'm going to kind of take what we just learned on the previous page, and I'm going to rewrite this as, instead of the cubed root, I'm going to take x to the 6th, y to the 1st, and z to the 4th, and I'm going to take it to the 1/3 power. All right, so here's one equivalent way I could write this. I could also take this and distribute this 1/3 to each term. So here I have the 2. So remember, the 2 is consistently outside of the root. It has nothing to do with what goes inside the cube root function. So the 2 is just going to kind of hang out on its own. Okay, and I can sit here and I can make this now, okay, this is now x to the 6/3. This is now y to the 1/3. And this is now z to the 4/3. Well, we can also now simplify out this expression here that I just made, because x to the 6/3, well, 6 divided by 3 is just 2. Here I have y to the 1/3. And here I have z to the 4/3. Now z to the 4/3 I could actually rewrite as z to the 3/3 times z to the 1/3. Because of our exponent laws, these two fractions would add together to make 4/3. Okay, so let's even come up here a bit more. So now I have 2 to the x squared. And notice you can just keep going with this. So here's y to the 1/3. Now z to the 3/3, well, that's just z to the 1st. And times z to the 1/3 power. Well, 1/3 I can now make this even back in our root function. So I can even make this so anything with a 3 in the denominator would go underneath the cube root. So this would be the cube root of y to the first and z to the first. But the x squared does not have a 3 with it, nor does the z. So I can rewrite this as this. And now I've kind of simplified our square root. I could even at the beginning have split up the square root, or the cube root, I should say, sorry. Cube root, we could have made this 2 times the cube root of x to the 6th times the cube root of y to the first times the cube root of z to the 4th. Now you can always split up your cube roots. We could even have moved this 8 back in, so you could have made this the cube root of, well, if I move the 2 back in, this would have to be 2 to the 3rd power, because the cube root of 2 to the 3rd would just be 2, and that would move outside, and then x to the 6th, y to the 1st, z to the 4th. So there's many different routes you can take as you're going through this. I would probably recommend just following a line and just kind of keep going and explore it on your own so you can start really understanding where these fractional exponents are going and what the real relationship is with the radical. All right, let's maybe think about another one. All right, so here's one that kind of already kind of had split up for us, but we can make do with it. So the first thing I kind of would like to do, looks like this -2's out here. Let's distribute this guy into everything. Okay. Now remember, you can only distribute exponents in this situation. If it were x plus 2 to the 2nd power, you don't distribute the square because it's separated by a plus sign. It doesn't work the same way. Okay, so remember, it only happens when they are multiplied together. So don't try and get creative when it's an addition problem like this. All right, so here's 3 to the -2 power. Here's x to the -8 power. And here's y to the -14 power. And this is all still being multiplied by the square root of x to the 5th. Okay, let's see, 3 to the -2 power. Well, these negatives all mean that these become fractions. So we can actually just put all of these in the denominator. 3 squared, x to the 8th, y to the 14th, because they are all negatives. Negative move to the denominator. The square root of x to the 5th here is at the top. Okay, well, let's keep kind of diving in with it. Well, we just learned we can make this as a fraction, so numerator would be 5, denominator would be 2, because this is the square root. And, well, 3 squared is 9, so I'm going to make that 9. And here's x to the 8th, and here's y to the 4th. Okay. Let's see, we can even keep going a little further. Well, I can split up anytime you see an improper fraction. So that's kind of the nice thing about rational exponents, is the fact that, we've kind of done these moments in which we had to simplify a radical. It's a little easier to even see that you need to simplify it when you have this fractional exponent, because now I can see that I can break this apart. So I can make this x to the 4 halves times x to the 1 half. That would be the same as x to the 5 halves. And then over 9 x to the 8th, y to the 4th. So remember, these are all equivalent expressions to this. So here would be x squared, x to the 1 half, all over 9x to the 8th, y to the 14th. I dropped the 1 somewhere. There it is. Okay, go back to that 14. Here I have x squared and x to the 8. We can subtract these exponents. So this would end up just being x to the 1 half over 9, x to the 6th, y to the 14th. And you can even rewrite it back. We can make this square root of x over 9x squared, or x to the 6th, sorry, y to the 14th. Now, so many routes we can end up taking with this, but as long as you kind of see through and one step at a time, and all of these are equivalent to what came before. Okay, so it allows us to kind of manipulate this thing even as we're maybe simplifying it down to the most simplified form. Allows you to kind of play and understand what those exponents are. All right, this is basically the equivalent form. So yeah, definitely I would recommend on your homework, if you're having a little trouble with it, just really kind of stick with one. Try and go as far as you can and play around with it, so it just starts making a lot more sense in your own mind. And we'll be back then for video 4, which will be solving radical equations. So have a good weekend.